Hi everyone, this is a demo for the paper Building Knowledge Graph from Public Data for Predicting Technology Future in Space and Time. Our goal is to build an end-to-end system to predict the future centers of a technology in both temporal and geospatial dimensions. Right now, this task depends more on experts' views and manual works. But the system we built can integrate different data sources related to the technology and generate the knowledge graph to enable users to perform predictive analytic tasks effectively. Our system includes 4 steps. The first step is data collection and cleaning, and the second step is data modeling. The ontology is used to map data into a knowledge graph in RDF format. And the third step, we generate features by querying the knowledge graph. The features are used for next step. And the fourth step is the predictive analytics, and the user can use different predictive models. We are going to use the fuel cell technologies as a case study to show how our system works. The first step is data collection and cleaning. We collected 2 data sources. One is IEEE research papers and the second is USPTO patents. And both of them were crawled from website. And we are going to show you the data we collected is stored in the Elasticsearch. This is the patents data, and we can open an example here. We modeled a Ziny field here. And this is the IEEE research paper data. And this is an example here. We modeled the author field here. In the next step, we use a spatial temporal ontology to generate a knowledge graph. The third step, we query the knowledge graph to generate features which are used for the predictive analytic tasks. And the SPY query are used to query the graph. And we are going to show you an example of SPY query. This is an example of SPY query, and it asks the graph the total number of patents in adjacent cities of Chicago. And we can run it in the command line. We can see the output is that there are 1,944 patents in the adjacent city of Chicago. And because of the time limitation, we're not going to show you all the SPY queries we use to generate features. We wrote the Java codes to generate feature vectors for the predictive analytics. And this is the feature vectors in the training set we are used for the predictive analytics. And in the last step, we are going to show you 2 models here in order to show you the advantages of our model. The advantages of our model is that the user can switch different predictive models with different feature vectors by querying the knowledge graph easily. One the model we are going to use is the support vector machine, which is a non-time series model, and the second is multiple hidden markov models, which is the time series model. First, we put the training set into hidden markov model, and then the same training set we put into the support vector machine. And then we are going to show you the outputs of the hidden markov models. And then is the support vector machine. And we're going to publish the outputs of both models into the Elasticsearch to see the performance of two models. Then first, we publish the outputs of the perfect machine, and then the hidden micro models. And this is the data we just published in Elasticsearch, and we use the tool in Kibana to do the data visualization to see the performance of two models. And we can see the first column here is the ground truth, and the second column here is the outputs of multiple hidden micro models. And the third column here is the outputs of the support vector machine. First, we zoom into United States. We can see there are two centers in United States, and both models can predict two centers. And then we zoom into Germany, and there are two centers here, but both of the models can only predict one of them. And at last, we zoom into Japan. We can see there are two centers in Japan, and multiple hidden micro models can predict both of them, but the support vector machine fails to predict one of them. So we can see the performance of multiple hidden micro models is better than the support vector machine. So maybe the time series model performance is better than non-time series models in this kind of problem. So this is how our system works. Thank you for watching.